Nouveau professeur à l'UQAM, au département informatique, une star montante en génie logiciel. Elle vient de Concordia. Et je pense que tu as prévu de parler de toi un peu au début. OK. Donc, bienvenue à Diego et bon séminaire.
Merci à tous. Je vais malheureusement faire la présentation en anglais parce que apparemment on ne peut pas maîtriser la langue en 2 semaines. J'ai commencé mon cours. Donc, si vous êtes à l'aise, vous pouvez poser la question en français. Je vais faire mon meilleur pour répondre en français et en anglais. Okay, so thank you so much for coming. Again, I'm Diego. I've just started at UQAM, and I will talk today about a topic that is very dear to me. It's very interesting for software development, which is dependency management. So, okay, just a few, actually just one slide about me. I'm from Brazil, as many of actually my compatriots here are. It's quite amazing to see how many Brazilians are coming to this region in Canada. I did my bachelor and my master in the Federal University of Uberlândia. I worked in the industry back then as a development of stock trading market systems. So those robots that nowadays basically manage the stock trading market. Then I got a scholarship to do my PhD in Heidelberg in Germany, which I also worked at as a software developer in the technical department of the university. And then I thought, okay, I experienced some flavor of winter, but I kind of need to meet the real winter. I need to get to know the poutine and then I came to Montreal. I did my postdoc at Concordia for 3 years, and just recently I started my position at UQAM. So in terms of my research interests, I've done a lot of empirical software engineering. That means we put on our mining hats and mine software repositories to try to understand the challenges developers face when developing software. And some of the areas I applied my research to is dependency management, which we'll be talking today, performance engineering, and more recently, software engineering for AI-based systems, which is also a very promising area. Why dependency management? So the first thing you have to understand is the way we develop software has changed. Right? It used to be in the 90s that you would get to develop your full application. You would develop mostly of the functions. You would only use a few libraries and the standard library. Developers would have ownership of their code. Nowadays, it looks more like this futuristic sort of engineering of buildings, right? You reuse a lot of components. We reuse libraries. We reuse frameworks. And all of this to improve software productivity. And just a small caveat, whenever you have a question, please raise your hand right away. I think it's easier for us if we actually go into the questions. And the reason why we reuse so much code, we use libraries, frameworks, is that it became quite easy to do so, right? And this is due to what we call software ecosystems or ecosystem managers. If you program in Python, you know what PyPy is, because you probably had to install many of the libraries using PyPy, right? Java for Maven and JavaScript and NPM. All of this makes using other people's code much easier. It used to be the case that you had to install the library, then you need to go and install the dependencies of that library, recompile the library for your system. None of this is needed today. The only thing you need to install a new library and reuse other people's code is just a command. I can just go pip install my package, Maven install my package, npm install my package. And that's all you need to do. Everything happens in the background, install a lot of libraries, and you're good to go. Okay, and that has changed how we actually develop our software. It's estimated that 92% of industrial applications use open source components. And more than that is that if you take the components of a software application, if you take every 10 components that they deploy, 8 come from open source components, like the open source world. We're talking here about infrastructure, but also about code. So we use extensively open source components. Of course, it's not all good news. Otherwise, I wouldn't be here talking about a research proposal. There's a lot of complexities that come with reusing open source code, and here's an idea where the complexity comes from. Okay, so this is a dependency graph of 10 of the most used NPM libraries, of JavaScript libraries. Right? So each node is a library, and each edge is another dependency that's added to your system. So if you decide to use this library, you're gonna actually embed in your system dozens of other libraries that you have no control over, and you don't even know they exist, and that there are dependencies of your dependencies, the so-called transitive dependencies. Yeah. So here's the problem: if there's a bug in this library here, does it affect your system? If there's a security vulnerability in this library, does it affect your system? And those are one of the biggest challenges in software development when it comes to dependency management. Hard to trace, and the impact is quite meaningful. Right, so that complexity that one library brings dozens of other libraries translate to many of the maintenance challenges today. Developers complain about updating packages and bugs in the libraries that are very frequent. And while the elephant in the room, security vulnerabilities are very common. Right? So 1 in every 10 components of download systems, according to the supply chain report, have known vulnerabilities. And if you take only like the JavaScript rule, right, the NPM, 40% of all NPM packages are known to rely on code with known vulnerabilities. So it is widespread, right? It is not theoretical at all. So here's an example of a case in which a data breach happened in a US system, actually leaked a lot of US citizens' data, including the social security code, and cost Equifax almost $1.8 billion in security upgrades and settlements, just because this was a big security flaw. All of this was caused by one vulnerable dependency in their system, the Apache struts. Vulnerability was reported. It took a month for Equifax to understand that they were affected and to fix it, and that alone caused this big data breach. So this is just a preamble of the talk today. I'll talk about kind of 3 stories on managing dependencies. The first one is related to the problem of finding the needle in the haystack, finding the right library for your application. Second one is about adapting. So once you take a library from the open source world, you have to adapt to your own context for performance reasons, security reasons, and so on. And finally, we'll talk about the fire extinguishing part of it, which is responding to security vulnerabilities, and where like time to response it's key. So any questions so far? I'm actually on some water because my mouth is super dry because of the coffee, but I didn't see. There's no water, right?
No, I will.
Lesson learned of the day: don't drink too much coffee before you have a presentation. Thank you so much.
Let's see.
Perfect. So this is the 3 stories I'll talk today. Let's start with finding good, I would say not good, popular libraries, and what are the problems related to that. So the main problem here is that ecosystems are growing, right? People publish their packages all in right, and you can see here the NPM, Maven, PyPy, they grow super linearly. Like here, the axis is actually a log. And NPM today has more than 2 million usable libraries. So finding what you need might be difficult, right? Here's what developers do. They start saying, well, let's get a date parser component, a component that helps us manage date formats. Like some countries use month, day, year. Some other countries use day, month, year. You want to have a library to handle that for you, so you don't have to worry about it. If you go to the NPM web page and you try to find a data parser component, you find more than 2,000 options available for you. So what developers do, they pick the most popular, right? What everyone else is using as well. In this case, the most popular is the moment.js, which is the most popular library, one of the most popular libraries in the ecosystem. The problem is that library is already a legacy project, and it has been for a while, for many years. So if you're familiar with the JavaScript ecosystem, you know that that library got popularity like 2015, and then it's kind of bloated nowadays, has a lot of functions on it that people don't need to use. And then you have newer and better available options to use today, right? And you do not want to use a legacy project in your system. You don't want to deploy to the client code that is no one else is maintaining. Right? Why is that the most popular library is a legacy project, and why are people still choosing from? The problem is how we measure popularity. So here I'm showing two of the most important metrics developers use today: the number of dependents and the number of downloads per month, right? Which is quite intuitive. If you have a lot of downloads, a lot of dependents, that means that library is quite popular. The problem is if you see when the library became a legacy, those metrics are not going down. They're just going up, right? So legacy, if you know this ecosystem, you know people are not using Moment.js as they used before. So what did we think? Okay, how can we better measure packages popularity? The idea here is just to treat the big ecosystem as a big network, where nodes are packages and edges are dependencies. And in those particular cases, we have already a good metric for measuring importance of a node. It's called node centrality. So if you come from networking, these metrics are all social network. As a matter of fact, those metrics are very commonly used. We decided to use PageRank, which is the one that is used by Google used to be used by Google back in the day to measure popularity of links and websites. So if you were to plot the centrality here, you can see that that package is declining long ago, right? And it's a bit of how if you're part of the ecosystem, you already feel that. People are not using the library anymore, but those metrics that people normally base do not reflect that. Right? And the key problem of that is that those metrics have a big inertia. Once a package becomes so popular, you will never decline the number of downloads and dependencies. It's because the ecosystem is also growing, right? So can we use centrality to better detect the decline of a library in the ecosystem? This is what we did. We did a study in TEM where we evaluated two things: how accurate is using centrality, and how far in advance can we detect, let's say, packages that are become deprecated, that no one is maintaining anymore. Right, so here's what we did. We built the entire ecosystem graph over time, every month. Then here you can see, the red package is quite central. And then it starts losing centrality because people are migrating to the blue package. Right? So once that is consistent over time, more than 6 months, we will flag the package as in decline. Community interest is declining there. You should perhaps think twice before adding that library to your own application. Okay, so we report that packages in decline. And how effective it was, we evaluated on 4,500 packages on the many different metrics. And we found that our approach was 80%, has a precision of 80% and recall of 87%. Right, in declining packages are in detecting packages are declining in community interest. More important than that, as a matter of fact, is how far in advance can we warn developers, look, this library, people are not using it anymore. Perhaps alternatives for that. Right? And we found that this metrics very sensitive and can find this 12 months before what people are using today, which is the NPM score. So people nowadays, they use the NPM score to verify if a package is going up or down in popularity. Our metric can detect the decline in popularity much sooner. So you know a year before that maybe you should choose a different package if that's a core component of your system. And also interestingly, 16 months before packages become deprecated. Right? So that shows that the community reacts, but that information is kind of hidden for most of the developers. Okay, so that's kind of the end of the first part. Again, we found that centrality is a way better metric to understand community interest over time, and that we were able to identify a year before or 60 months in advance before packages become deprecated, just because looking at the ecosystem allows us to react faster to community interest. Any questions from this first part so far? Yeah.
Just add a question about the weekly download metric, NPM, for example. What do you think about it? Is it like a good metric for?
So it is it is, so that is exactly one of the metrics we compare to. And here's the problem of downloads. So downloads measure the number of installed systems. That means one project, let's say we developed a project and the Canada government uses that system. That means that every public servant, when they updating their systems, will download the package. So one project, our decision may reflect to millions of downloads, right? And that is not a good measure for community interest, but rather the number of installed systems. So you have this discrepancy that is, one system may be responsible for millions of downloads every week, just because it's widespread.
Diego, do you imagine there is a correlation between centrality and software quality, code quality? You guess like something like that?
I think so. Centrality is very good to measuring popularity, my opinion. And popularity in open source systems has some implications. That means that more people are working on the project. That means that more people are using the project, which can flag problems of the library. So there is a positive correlation, but it's not everything. As a matter of fact, I would recommend someone to do their due diligence and look for libraries that fit their context. And when evaluating alternatives, okay, we have library A and B, they do similar things, but one of them are rising in popularity. That means people working on that library will be more motivated to continue supporting the library, right? So the open source world is this very different dynamic system in which the more popularity, more interest people have, more likely are people to work on that project and respond fast. And so I think there is some correlation, but it's not, you shouldn't first look for popularity, in my opinion.
What make people change from library A to library B in the first place? So basically you have moment and it's all other applications are centered on it. What does make someone else okay and choose another library if everything is centered on?
Perfect. So the way we see it is not that the library was popular because the metrics we evaluate were system based, or let's like I give the example of the number of downloads, right? So Moment will always appear, even today, Moment is the most popular by those metrics. But when we look at the number of projects using that library, the figure is different. We actually see a change over time. So Moment still, like if you're familiar with Moment, you start a new project, will you look for another library? Maybe not, right? You only look for new libraries if you have a problem or if you see that there is some solution that you're not really, you don't really like. But what we're trying to say is that even though some metrics put Moment as a highly popular library, it is in fact not the most popular library today if you go to the projects that use library. Doesn't make sense.
Yeah, it does, but what make it lose popularity? Basically someone new came and he will choose a library, and why did he choose another library?
The moment we know, because the moment even the creators of the library declared you should not use this library, there are better options out there and we will not add new features. Right, so the developers found out that the library is a reflection of a node world of JavaScript in which all the library is bloated. There's a lot of functions, but if you use that in your website, you might have performance problems, right? And it's hard to maintain. So new alternatives came up, like you see with technology, like you had Angular, then you have React. Like people are always finding new interesting ways of solving the same problems, right? And the popularity of those libraries are boosted by corporate sponsorship or support. That's one way. The other is the maintainers of the library stop maintaining, and in the moment they even declare, please don't use, look at the other alternatives better suit your library. And even so, even after doing this, you will still find Moment as the most popular in system-based metrics.
So the developer of Momento came at the 2014 or 2015, and they declared that there are other better alternatives.
Yeah, they say that we'll only maintain like quality-based bugs we will fix, but will not evolve the library anymore. Because they're not interested, because the library did solve the problems that it had to, but new alternatives, I think people are a bit more interested in. And so there's a bit the dynamics of those ecosystems somehow. Does that make sense? Thank you. And just to finalize, we actually published a tool. It's a Chrome plugin you can install in your browser. And when you go to the webpage of NPM, it actually shows the centrality ranking below the weekly downloads. So you can actually compare, right? You see the weekly downloads rising, but if the centrality is declining, it happens what I just mentioned. Like there's a lot of systems using, but not a lot of projects using that particular library. Perfect. So I'll jump to the second part of the talk. So we talked about selecting libraries based on popularity. Now we'll talk about selecting libraries and adapting them for performance reasons. And this is about Java world. This is a work I did back in my PhD. And it's about data structures. So we all know data structures, algorithms are the bread and butter of computer science, software engineering, education. We need to select our data structures, yada, yada. As a matter of fact, in the Maven ecosystem, there's so many different libraries you could choose from. They all have some different performance trade-offs, right? So just an example of a set implementation. If you want a general purpose implementation, you cannot go wrong with default hash set. It will serve you well. Right? If you need fast iteration, you can have the link to hash set, in which the way the memory is organized makes it for fast iteration. If you want a lower memory overhead, you can go for a different library, fastUtil, and then you have the open hash set, which just lashes the memory you would use with the original hash set by a quarter. Okay? Or if you hold primitives, your hash set only holds integers or floats. You don't need to use the default implementation that backs them back to the object version. You can actually save a lot of memory and execution time by getting specialized data structures. Right, and that's, again, that's not a theoretical impact. These are 3 studies that evaluated on 3 different dimensions: execution time, memory usage, and energy consumption. The impact of tuning one allocation site, one place in your code, they have a huge impact on the overall performance of an application. Right, so those are studies, nowadays a bit old, because that was my references when I did my PhD, but it still holds to this day. Like if you choose an array list instead of a linked list, you can have 300% improvement, and that was a JSON implementation of Google. Okay, so it is a big problem, but how can we help developers at selecting the data structures for their programs? So this is a kind of an array of a couple of works where we studied what developers use. If there are better alternatives out there, how can we automate the selection to take the burden away from developers? Here's what we did. We put on our mining hats. We started mining software repositories, 10,000 Java software projects. And we found that, to no one's surprise, developers rarely select anything beyond the most commonly used default data structures. Right? 95% will be traced back to those 4 different types, all from the standard library. Can we find better alternatives to that? So here, what we did in a follow-up work, we built a huge benchmark suite in which we could control the scenarios of evaluation and compare performance across different implementations, right? So I don't want to bother you with the entire thing of the heat map. The only thing I want you to see, green cell means switching to an alternative would give you performance benefits. Red cell means if you switch, actually lose performance, right, in terms of time. And on the right side here, we also have in terms of overhead reduction. So if anything, if you take one thing from this particular part of the talks, that linked lists are not performance effective. Okay? That's something already quite well established. Even in cases where they should do better, they don't because of memory locality or all of that. So we found that it's not so clear cut. So for linked lists, almost all alternatives outperform. But for all the data structure, it depends on the case. You see some green, some white, which means no difference, and some red. Here again, we found a similar thing for primitives. So if there's so much, it requires you to fine tune to such a specific scenario, how can we harness the benefits of knowing this to automate the selection from developers? Because asking them to trace back where their scenario goes in their system live in production, it's quite difficult. Okay. So here's what we did. This is the idea of the automation. On the left side here, you have a simple array list, and then you have a lookup under a for loop. Lookup, as we know, is linear on array list because you have to search for the entire element over the entire array until you find it. So that means if the collection size grows, you start having performance problems. If it's 1 million elements, it may take you 20 seconds to find the element. What we propose is, instead of developers instantiating the array list directly, it instantiates the context, and that context can then switch based on the workload of the application in runtime. Okay, and then switching and knowing, okay, like past instances, we had an increase in collection size, which is the y-axis here. You can switch to a different type to mitigate performance degradation. Okay, in this case, you could switch to an array list with backed with a hash table somehow. So this is the idea of the approach we propose. It's called collection switch, and it's switch like a railroad switch in a way. That means that collections are created based on the workload of the past. Once the collections are created, we don't change it anymore. So the next one that's created has more information because we keep collecting information of the program at runtime. And that's the idea of the collection switch. We use our benchmarks, all of those heat maps I showed you before. We build models with that allowed us to then switch to different libraries or implementations at runtime without incurring too much of a memory overhead. And here's an example of a scenario dominated by lookups. Over time, the collection size increases. The blue line is the array list, while the other one is the collection switch. And you can see at some point, it switches to a more efficient implementation based on the collection size. Okay, that's all good and dandy, and the idea it kind of works well, but can we improve real applications with that? It turns out, yes. We got some benchmarks from Da Capo back in the day. And here we run Apache Lucene benchmark. We found we could get faster, 15% faster and 8% lower memory allocation. We are optimizing for different goals. Remember, like time and space trade-off. So when you run our framework with execution time in mind, you may actually get more memory allocation. With H2 database, we found exactly that. So when we tried to improve memory allocation, we got 11% slower. Interestingly enough, on bloat, here we got both. It's kind of too good to be true. And we were to investigate this, is that when we optimize the memory of the program, the garbage collector didn't have to run as frequent, and we got some performance improvement as well. All right, so just to recap on this part of the talk, we found that developers rarely go beyond the most commonly used data structures. There are good alternatives out there, libraries that can improve the execution time and memory footprint of applications. And we propose an approach that can do that at runtime, that optimizes and changes data structures to effectively optimize the application's performance. Questions about this part of the talk? Yeah, Cristiano?
Does it hold true for the new versions of the ETK?
That's a great question. So we would have to run benchmarks all over again. Let's see. My gut feeling is that some things would hold because it's about the design of the way the data structures are designed in JDK. There are a few things that it's not likely to change because of backwards compatibility. So the memory part will hold. Now the execution time is a different story because JIT optimizations and Java optimizations can make it more difficult to optimize things. Yeah.
Do you remember the version that you used at the time?
We probably use either Java 8 or 11. Was not anything newer because this work is only what 16, 17.
Yeah, it's not that old.
Mm-hmm. I think most likely Java 8, but yeah, we have to check. Yes.
Look up to the 40, slide 40, how you manage the slide 40.
Yeah, in the slide 40, yeah.
How you manage the next path, for example? Yeah, you go from based on the context, you change to another library, for example, instead of using the list or my list or a list, go to set list or so when you you do something like artificial intelligence stuff here to remember all the history and based on this artificial intelligence information and go ahead and make some prediction?
Yeah, no. As a matter of fact, we use very simple models. We played a lot of this. The problem is that if you try to do too much computation while trying to optimize the program, you incur in too much overhead. So we actually end up having very simple rules for how to decide, but the performance in itself, it's a linear model. Very simple that you monitor the collection and you have, oh, this collection has that many lookups. Then we have a cost function of how much a lookup on that size costs. Which is just a linear function. And then we, based on, let's say, 20 instances, we decide maybe the next time we should change. But we don't do a more robust thing, learning, because in fact, this is not really learning, it's more adapting, right? You need to adapt. The idea was that workload of a program would also change. E-commerce system on Friday and Saturday will have a higher workload and come back. So we didn't want to make it as a learning, more as an adapting kind of problem. So we went with simple rules, and that was difficult enough. Yeah.
Besides the rules, I think that to my understanding, for example, contains, you will add some instruction that will each time you call contains, it will plus one or something.
Yes.
Like
Yes. Simple counters.
yeah, and this doesn't add
Overhead.
yeah.
Well, as a matter of fact, we evaluated this and we've controlled benchmarks, micro benchmarks. We measured that if you monitor the 100 instances, there is an overhead that's measurable, but it's nanoseconds. So when we run the applications, so we did this test with real applications. So we run the test with real applications. What we did is that we run those same benchmarks, but with an impossible rule to make. So only the monitoring will be measured, the difference, and we will never switch anything. And we didn't find a significant change on big benchmarks. But if you measure at nanoseconds, you find about 20 nanoseconds if you're measuring 100 of instances and so on. So the key idea here is that we only basically counting things, but we never switch back instances. We never copy memory the collections back. So that takes a lot of the overhead out of the equation.
In terms of dynamic analysis, so to come back perhaps for the collection size, so you execute a certain amount of scenarios. My question is, how many? What is the test coverage? Will you be able to cover all cases? Can you estimate that? How did you perform the dynamic analysis?
Yeah, that's a very good question, because we had to actually approach this in a different way. We decompose in terms of operation cost. So I know, for instance, how much a operation will cost, varying the size of 10 elements to 1 million elements. So I have a line of cost function for that. But I don't have a scenario that's more complicated than that, right? So I don't know, for instance, if the collection adds 1,000 elements and removes 500 and adds another. We don't know that. We only have the number of operations called, and we record also the size over time. And then we compose this in a linear function. So I know how much each operation costs. So I just calculate the sum of it at the end of that collection instance. I do not have, it would be impossible to cover more complicated operations and sequence of operations in the benchmark side. So we approach it at each operation cost somehow. Does that make sense?
Okay, I see. So you did not execute concretely some scenario on the...
No, yeah. So it's not a complete scenario. It's actually based on the operation, the dominant operation. Yeah. Very good. Okay, so we can pass to the final and third part. I don't know how much we are in time. It seems that we still have some time. Okay, now we're talking about responding to dependency issues, sort of the fire in the hole here of the problems. And here the idea is, if you use libraries, GitHub State of October says that you have 60% of chance of receiving a security alert in a period of a year. right? So if you use libraries, you're gonna have security alerts in your system. So you have to respond to that pretty fast. And just to give you an idea, this is the work we did in the Python ecosystem, which were actually quite super interesting because we were characterizing the life cycle of a vulnerability. We found that it takes 3 years to find a vulnerability. So once it's being mistakenly added in the code, until it's reported to the advisories, it's 3 years, right? That means once it's reported, most of the recent versions are affected. Right? And worse is that once it's reported to the advisories and the fix is provided, that means you as a client of that library, you can update to get the fix. It takes 7 months for applications to update their libraries. Right? So there's quite a lot of time for a vulnerability to be exploited if there is such a case for that. So again, we need timely updates. The problem is we use a lot of libraries, right? To use the ones you depend on, they are transitive. How do we manage what kind of update you want? And there's different kinds. I'm not going to bother you with what kind of those updates mean, but these are different granularities of updates. We can get patches, minors, or majors, which means it may even break your API. So how this is handled is through policies. So you can define, when you add a library to your program, you can define a policy in which whenever you run the update command, that policy will tell what kind of update you're going to get. All right, so that means you have the policy of no update at all. That means I don't care to update the library. You have only patches and minors, or all updates, which is kind of it's a spectrum of trust here. No update means you don't really trust any update is going to benefit you or may even break your code. All in all updates, you trust so much that you're willing to go and fix your code whenever a major update comes through. Okay, and the idea was, since updating is so important, what are the consequences of those policies for software maintenance? So we asked developers, and we did a 2-part survey, 12 participants and 41 participants, and we found that one of the policies is considered majorly to be a good policy. It gives you a good trade-off between I get the updates I need, and it's unlikely to lead to breaking changes, to break my code. On the other hand, we found that all the other 3 has problems developers talk about. Right? We found that no update increases bugs and vulnerabilities over time because you're not really updating, and whenever you need to, you'll be so far behind that you have to do so much work that costs you, right? Only patches may create extra overhead, and all updates is guaranteed to lead to breaking changes. So if anything, we have 4 of the most important policies in which 3 are considered to be harmful for software maintenance. And this is the core idea of the dependency smells in JavaScript projects, which is a term we came up with, which tells you it's a policy that is not necessarily a problem, but may cause over long time maintenance issues. And we wanted to investigate from the dependency smells, these 3 practices, how prevalent they are and why developers use them, since they report to know that those are harmful. Okay, so here's what we did. We analyzed 1,000 JavaScript projects again, and we found that some of them, the harmful policies are quite prevalent. So 52% of the projects have at least one no update policy. That means they either don't care or they decide not to update their libraries in some cases. More important than that is that those policies, so that means developers don't trust the maintainers of the packages they use. Most importantly is that it is accumulating over time, right? Even though there is some effort in reducing those harmful policies, it's accumulating. But why? Why developers decide to use policies that then they even report to us to be harmful to begin with? So to understand this, we did a sort of a firehouse interview. We monitor our projects, and whenever they switch from the good to a harmful policy, we ask them. Right? So we see that you're changing this policy. What was the cause of it? And we found some very interesting things. The most important one is that breaking changes cause most of the developers to abandon updating their libraries at all. That means they were updating regularly every release or so. Then at some point, it breaks their code and they decide, okay, it's not worth it, stop. Second reason was even more meaningful because it is like the developer said, I think it's the result of several incidents. So it's not even that library broke their code, but that happened so many times with other libraries that they stopped believing in updating their dependencies at all. It's a big mistrust in the community that causes this. Okay, so essentially what we see here is that developers are reacting to problems. They depend on, they increase their productivity. However, of course, those libraries have sometimes questionable quality aspects, and they have to constantly be reacting to updated dependencies and solve bugs and security issues. Once again, we found that those dependency smells are quite prevalent, accumulate over time, and they are a matter of reacting to bugs and breaking changes developers face them. Any questions about this part of the talk? Yeah,
No. Sorry, not sure if I get it right. When you said that all the updates is certainly to break the changes.
To cause breaking changes, yeah.
Is it your result or you're based on the other results?
These are the result of the surveys we did with developers. So we asked them, okay, what are the approach you use? What are the pros and cons of each policy? This is something that they come up with, and then we evaluated in a second survey with 40 if they agree or not with that. Okay. Yes, Ahmad. Go ahead.
Yes, hey Diego. First of all, thank you for the presentation. Actually, the results for this study was quite interesting. I'm wondering how the results are or can hold for the machine learning libraries.
Ooh.
So, for example, do they update? Maybe does it worth to update the libraries so maybe I can gain more performance? I mean here accuracy, or maybe less variability in the pipeline or in the prediction. What do you think?
That's a great question. Actually, there is a study there to be made. I know I actually have some hidden slides. Maybe I should put them again about the practices of machine learning community on dependency management. I do know that they have a lot of challenges in updating libraries and put them in production. I don't know if the results would be different for machine learning libraries because we didn't look specifically to that. But I think it might be some interesting study to be made. It is to see how ML project maintainers handle their dependencies, which I don't think there is a study out there. So just contact me. We can arrange this somehow.
Yeah, sure. Thank you.
Yes, there's also, I can read. Arion, go ahead. No.
Your microphone is mute.
Thank you very much. Very interesting talk, way out of my field. I'm dimly understanding what you're saying, but when you mentioned patches, that brought my attention because in general, I found the software work, patching is one of the most dangerous things you can do. In telecommunication systems, we have dreadful accidents happening because of simple patches. So wouldn't a priori patch be something one would wouldn't exclude? No.
I didn't quite get the question, but I understand you mentioned like patches are something dangerous.
I'm sorry. I my own work in the past in software, patches were always considered extremely dangerous. A small patch can bring down, if it's not done right, can bring down a whole system. This happens in telecommunication systems from time to time. And so I'm wondering, would you not wish to exclude patching a priori because it is just inherently too dangerous? That's
a great point. So I feel there's also even different, let's say, cultures depending on what you develop. So what we asked here was mainly the open source community, and they seem to value constant updates. But I think there's very different in industrial and closed-up or real applications that you have to develop, in which I know the culture, it is to have it more as stable as you can. So you always pin down the dependencies first, and only when you see reason to update, It's what you do in industrial applications, right? So there's even a difference in culture here. Our results really speak more to the open source side of the world, in which they seem to have a understanding, at least for the JavaScript community, that constant updates or constant updating gives you actually a head start, because problems are so common and you have to update them anyway, that letting them be part of your release somewhat culture or practice, it's the way to go. But I have received actually some different opinions from the industrial or closed source practices, that they are way more careful, and the practice is actually to pin down and not update until you have a good reason to do so. Does that make sense?
Yes, for the time being, I understand. Thank you very much for that sort of simple question. I'm sorry to bother you with it.
No, that's a good one.
Thank you very much.
Thank you. So I think,
Did you identify the best policy based on the survey that you did with the developer? So
Yes.
they chose the best, they were the one that chooses the best policy.
exactly, yes.
And don't you think it's not that, cannot be that accurate? So basically, theoretically can be any of the other that should. There should be a theoretical study on this, but not based on the opinion.
I wonder, yeah, that it could be. We have a follow-up study on what actually is adopted. And we know that, for instance, the open source world tends to side more of the what they call SIMVER compliant, which is the good policy I mentioned here. Whether that impacts positively or negatively, it's an evaluation that we could make. It's just a very difficult one to be made, because if you think about it, you have to associate causality between the dependency update practices and some other metrics, let's say quality or responsiveness to issues, right? So our route was a bit of a, let's see what practitioners think of them, and then let's qualify. And we also add our own research on some aspects in which some of them are clearly bad. So I only presented 4, but in the paper there's 7 of them. And there is, of course, using URL as your dependency tag, which is very dangerous because it's not going through NPM and can cause a lot of sorts of issues. So some of them is open to debate. There's 4, I guess. Some of them are clearly bad cases, like unused dependencies and so on. But it's a good one. I think if we have energy and time, that would be a nice thing to investigate. I don't know why my thing stops working from time to time, but that was basically what I had to say. There is just a quick thing I wanted to convey, which is today the ecosystem is quite opaque and reactive. That's to me one of the biggest problems of dependency management. That means I develop a library, and my bug in my library may affect all of you, and all of you will have to debug your own code and find solutions individually and separately over and over again. There's no much of coordination that could be done, but problems do affect you, but solutions do not. So Fabio may develop a solution that Noel will only find a month later, right? And unless Noel knows that Fabio's project is dependent on finding the solution, there's no coordination. I think that's something we need to improve. And secondly, it's to have a system more transparent. It's very difficult to find, even if you're affected by security vulnerability. So the Log4j incident, I will close with that, caused millions of systems to be affected. And I talked to companies that they struggle for months to even map which systems of them were affected or not. So we are really in the infancy of having a more intelligent dependency management, which we need to push forward. Yeah, and the final thing I want just to thank, this slide is nice, but I want to thank all of the collaborators and everyone. This is a work done with many, many people. And I will just end on this slide in case there are more questions to be made. So thank you so much.
So you suggest as proactive solutions to monitor the ecosystem both as an agent of ecosystem. I guess it's your NSERG research proposal.
Pretty much.
Great.
So could you tell us about what concretely solution you offer for all the problems?
Of course, there's no one dying to just joking. Yes, so there are many things we should start doing in terms of coordinating in the ecosystem. One thing that is to me very clear is that the point of understanding the community reaction and using that as a beacon to warn developers. What I mean by that is, you know, we have a lot of public, we made a lot of recommendations on products based on how public reacts to them, right? That means, well, they were using this particular product and then they started buying these other products as well. What I mean here is maybe we can use the ecosystem, the way they react to issues to warn other projects. Like Fabio found a solution. He downgraded because he found a problem on my library. Maybe we have to develop solutions that help everyone else understand what is happening in the ecosystem. So increasing transparency, that means maybe suggesting your project a patch that Fabio applied to his project to fix, right? There's also the point of community CI. That means I don't need to wait for my library to break your code to then apply the fix. I may be able to use your own tests to verify if my new release breaks my client's code. Right? It's all about harnessing what the ecosystem has in terms of data and developing risk models. Right? So an idea that I had is you should know how that team reacts to issues before you select their library. Right? If they, in the past, there have been several vulnerabilities that team has not fixed on their library, maybe you shouldn't select that particular library to your system. Right? So it's about giving more information. It's about basically understanding better the ecosystem and how good projects react to them and using this as a tooling device somehow.
Recommendation system.
Yeah, a bit on how Dependabot works today. Dependabot is a very effective, noisy and a bit annoying, but very effective at warning developers about issues in dependency. I think we need to expand that to other areas as well.
Okay, I got a question. Very good, huh? Very interesting. Thank you for the presentation. I'm always thinking on the business side of things a bit. So when you discuss the policies for the updates of the libraries, I was thinking that I don't know if that depends. It seems to me a bit like a one fits most kind of situation. And that maybe it depends on the impact of the update in the specific system and the project
and the component
that it's in general, huh?
Yeah, absolutely. And as a matter of fact, we speak about that in the paper, that you shouldn't have to manage so carefully all your dependencies, but the ones that impact the core of your system.
Exactly. There is some context that needs to be taken into account. So I was thinking that developers shouldn't be making those decisions by themselves. It's something that it's technical for sure, but there is a business side of it.
Yes,
it depends on that. If there is no impact, maybe I have no updates.
I love this because this is exactly the paper. I don't know if Stan is still with us, but we got a paper with Afed and Stan that we work exactly on this. So it is a approach that the company, thank you, approach that the company is pulling to control the open source usage in all of their systems. So the company is defining the policies, right? So to have a more shared responsibility between the team and the business systems.
I'm thinking that it's too much. The developer to know all those things, they won't know. They just won't. They'll just take a guess. And that's not good enough in the business world. No? That's not good enough at all. Absolutely. And the same thing happens in the first part of your talk. So you have the policy on one side, and on the other side, you were talking about the security vulnerabilities, and then how to select based on the centrality, which is very smart. It makes a lot of sense because you get the pulse of the community. That's really good. But at the same time, you have the license of the library.
Yes.
That once you embed the library, even if it's vulnerability free, it's gonna bring maybe an MIT license or maybe a GPL license, and those things, if you embed that into your system, that may be like calm like a bone.
Yes.
But it's gonna be like the legal department that is gonna call you, not any technical issue or
exactly. So ultimately it is, and I think companies are now learning how to do this better. So for example, SAP, it's a company that we work together and they have their own department in which they have a repository which they grade. So there's a team responsible for grading open source projects and selecting and centralizing this. So companies, especially the ones that more advanced on this, they have their own ecosystem inside the company. They don't pull from the open source. Right? So they have their own versions and they control that. And sometimes they pull in-house for
distribution of
finding the solution. Yeah.
the whole thing. But I was thinking that there is this process of deciding what to do with the library, that this decision process, it must be, I don't know, taught or explained to people that it has different sides of it. Don't make the decision by yourself.
Yeah.
Consider different issues, not only technical issues, but managerial, business issues that are very important.
I agree. And for the companies I work with, some of them are very advanced on this. Some of them are still the developer owns project, and that can be dangerous as well.
Exactly.
Right. So that's exactly the paper we published with Stan, and I think he joined early on, but I think he's not there. And he was doing that for the company. He was developing the policy and how to. He even found, okay, like our systems depend on 20 different versions of that library. So it then comes a security issue. How do you respond? You have even to find different strategies. Teams have to do different things. So we have to limit that, right? So it is about companies have to have more control, and they will I think over time develop this more maturity and license. I think is one that's quite mature, that's well established. But in terms of versions or what library to choose from, most companies I know of still leave that to developers. Yes,
That's question. Come back again to the reusability again. When we talk about reusability, do you have some advice, some ideas, how we can improve the component to be reused, more reusability and more quality, software quality and so on. So this is one of the big questions, big problems. 4 years ago, 50 years ago, we started to say, okay, reusability, and now we are going to reuse the package and API and so on.
Yeah, so this is a larger than life problem, right? And there are some good things of how we develop in this. So if you think about these ecosystems, these are the largest, collaborative effort of delivering good quality software we ever had. Right? You have thousands of teams developing, and they could depend on each other. And there's some beauty on that. There's a lot of risk. Right? That it boils down to when you're reusing the code, are you reusing only the part you think you're reusing, or it comes with a lot of extra things that you have no control about, right? So I feel like we're very good at publishing libraries and publishing packages, and the growth of the ecosystem shows that. Now, the quality of those packages and what they impact your system is where the big problem is to me. So to me, it's more like, how can you make sure that your system, your multi-million-dollar system does not fail because of a component that you chose in 2012, right? That you don't even remember exists, which that's what happened a lot of the Log4j. Like that affected not only system we think of, like Minecraft was affected, the Mars Hoovers use, Mars Ingenuity uses Log4j in their system. So you have software running outside of Earth that uses that library. Of course, hacking that would be a bit more detailed, but just to show the prevalence, right? It's everywhere. And it's becoming also a national proposition to US has a lot of strong grants that have been granted this last year because of those big cases to try to establish a national control over what open source is used, because Canada uses a lot of open source code. And so, yeah, it's a big issue. It is not going to go anywhere. We're not going to start developing from scratch, but we need to select things better and manage better. Thank you. Yes, so it was a bit long, but I hope you enjoy it. And
Cool. Thank you, Diego.
Thank you, Diego. Very interesting.
Thank you very much. Most interesting.
thank you. Thank you.
No.